Hello and welcome back. So this is the third lecture session under Convolutional Codes. So in this lecture we shall deal with how to write the state table, the state transition table and the state diagram for a convolutional encoder. And we also need to know how to write the code tree, which we shall do that in the next video segment. Now given a convolutional encoder as shown, having a single input, two flip-flops and two outputs C1 and C2, which becomes the output. How do we write the state table? Now in order to write the state table, we need to identify the number of flip-flops present, which indicates the state. So now since there are two flip-flops, the condition could be either 0, 0. The outputs could either be 0, 1, 1, 0 or 1, 1, isn't it? So since you have two flip-flops, I basically have four states, and these four states can be written as state S0, state S1, S2 and S3. So since you have two flip-flops, I have four states. So if I have a single flip-flop, I would have two states. If I have two flip-flops, I would have four. If I have three flip-flops, I would have 8 and so on, right? So now the states are S0, S1, S2 and S3, and then I can give the binary description. So the binary description would be 0, 0, 1, 0, 0, 1, 1, 1. Now I can either write it in this way, or I can either write 0, 0, 0, 1, 1, 0, 1, 1 also, but I have chosen S1 to be 1, 0 and S2 to be 0, 1 because it becomes a bit simpler for us to write the state diagram. So next we move on to the state transition table. So in order to write the state transition table, what do? We first indicate the present state. So we have the present state of the flip-flops. So either it could be S0, S1, S2 or S3. So I have S0, then S1, S2 or S3. Now let me write the binary description. The binary description. For S0 it would be 0, 0. For S1 I have 1, 0. For S2 I have 0, 1. For S3 I have 1, 1. So this is the respective binary descriptions of the present state. Now what could be the input? The input here could either be 0 or 1. So if the present state is S0 with the binary description 0, 0, the input can either be 0 or 1. So this is the input. So the input data can be either 0 or 1. And if this state, the present state is 1, 0, that is S1, the input can also be 0 or 1. If the state is S2, I can either have an input 0 or 1. And if the state is S3, which is 1, 1, I can either have the input 0 or 1. Right? So therefore, the input can either be 0 or 1. So in that case, we need to define the next state. So if I have the input as either 0 or 1, and if the current state or the present state is S0, S1, S2 or S3, what would be the next state? So that is important. So here, to find the next state, so if the input is 0, so if I feed in an input 0 here, so whatever was present as the output of the first flip-flop goes to the next one. So if the input is 0, the next state would also be 0, 0. So I get 0, 0. But if input is 1, the next state would be 1, 0. Right? So basically it is a shift, isn't it? So you have a shift of the bits here. Now if the input is 0, the present state is 1, 0. So 1 comes here. So I would have 0, 1. And if the input is 1, I would have 1, 1. So this happens to be the first bit and this would be the second bit always, isn't it? So if the input is 0, I get 0, 0. And if the input is 1, where the present state is 0, 1, I get 1, 0. I would get 1, 0. And if I have the input is 0, and if I have 1, 1 here as the present state, The next state would be 0, which is the input bit, and 1. And if it is 1, of course I would have a 1 here. So the next state would be 0, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 0, 1, 1, 1. So here I've actually indicated its binary description. Right? So these are the next states. I've actually indicated the binary description. So let me write the states as such. So 0, 0 is S0. So the next state would be S0 here. 1, 0 is S1. Right? Next, here I have 0, 1, which is S2. Then I have S3. Then again I have S0. 1, 0 is S1, S2 and S3. So I have S0, S1, S2, S3, S0, S1, S2, S3. So just remember, this happens to be the next state, but here I have written the binary description first. So when I write the binary description, it becomes easier for me to indicate, because this is just an indicator. S0, S1, S2, S3 is only an indicator here. Right. So now to get the output C1 and C2. C1 is nothing but these three XOR, isn't it? Modulo 2 addition. And what is C2? These two given to a mod 2 adder, modulo 2 adder. So let me define this input as DL. This is DL minus 1 and this is DL minus 2. Right? Because this is obtained after shift 1 and this is obtained after shift 2. So I have DL, DL minus 1 and DL minus 2. So what are the bits? If I have the input state 0, alright, and then the current state is 0, 0, I would have 0, 0, 0. Here if I have 1 as the input, DL minus 1 and DL minus 2 would be the present state, isn't it? So it's going to be 1, 0, 0 because the present state is 0, 0. So if I input 1, I would get 1 here and I get 0 and I get 0 here. So how do I fill in this table? So this table would be the input 0, 1 and DL minus 1 and DL minus 2 would be nothing but the present state binary description. So similarly here I have 0, 1 the input and these two would be the present state binary description, which is going to be 1, 0. Next again I have the current input, which is 0, 1. Then the present state binary description, which is going to be 0, 1. And then again 0, 1 the current binary description, which is 1, 1. So next I need to define the output, which is C1 and C2. Now it is very easy for us to find what is C1 and C2. So what is C1 and C2? C1 is nothing but we need to perform modulo 2 addition of these three bits, that is DL, XOR bit DL minus 1, XOR bit DL minus 2. It's nothing but XORing these three. So if I have odd number of ones, the output is 1. If I have even number of ones, the output is 0. Right? So C1 is 0 XOR 0 XOR 0 is 0. Next, here it would be 1 XOR 0 XOR 0 is 1. Next, count number of ones. Odd number of ones, you write 1 here. Next, even number of ones, 0. 1, 0, 0, 1. Okay, so wherever you have odd number of ones, the output would be 1. And if I have even number of ones, the output would be 0. Now what about C2? C2 is these two. So C2 is nothing but DL XOR bit DL minus 2. So 0 XOR 0 is 0, 1 XOR 0 is 1, 0 XOR 0 is 0, 1 XOR 0 is 1, 0 XOR 1 is 1, 1 XOR 1 is 0, 0 XOR 1 is 1, 1 XOR 1 is 0. So this happens to be the output C1 and C2. right? So now after we have got the state transition table, the next job is to write the state diagram. Now to write the state diagram, what do we do? To write the state diagram, let me write the 4 states S0, S1, S2 and S3. Alright? Okay. So now S0. S0 is nothing but the present state, which the binary description is 0, 0. If input is 0, the next state is S0. Right? So if input is 0, the next state is S0 but with the output 0, 0. The output is 0, 0. So let me indicate output within brackets. So this is the input, this is the output. So if I am in S0, state S0, if input is 0, I come back to S0 with an output 0, 0. If I am in the state S0, if input is 1, I go to S1. If input is 1, I go to S1 with an output 1, 1. Next, if I am in S1, if input is 0, I come to S2. But with an output 1, 0. If I am in S1, if the input is 1, I go to S3. So input is 1, I go to S3. But what is the output? It is nothing but 0, 1. Next, if I am in S2, if the input is 0, I come back to S0. But what is the output? The output is 1, 1. And if I am in S2, if the input is 1, I go to S1. Input is 1, I go to S1 with an output 0, 0. Now if I am in S3, if input is 0, I go to S2 with an output 0, 1. So this is the output, isn't it? If I am in S3, if the input is 1, I remain in S3 with an output 1, 0. So this is how we write the state diagram. So to write the state diagram, definitely I need the state transition table. So of course we define the state table here, we define the states and its binary description. We have to write the state transition table, and once we know the present state, the inputs and the next state as well as the outputs, so then we can write the state diagram. So using the information given in the state transition table and in the state diagram, we can write the code tree. So using the code tree, we can also find the output for the given sequence of inputs. Now for the same convolutional encoder, we shall take an input sequence, right? And then we shall write the code tree using the state transition table and the state diagram. Okay, so using this information only, we should write this code tree, and we should also find the output, and we should look into it in the next video segment. So do not forget to like, share and subscribe, and click on the bell icon to get notifications of all the further uploads, and to watch all the other videos in information theory and error control coding. Click on the I icon or go through the playlist information theory and coding theory, and thanks for watching.